Alright, let's get started. So, let's see. Just gonna run this. The cube. Alright. Let's review the import here. Where did it take me? Import. Alright, that's cooked. I think I remember how to do this. We'll just let it boot up so I can see. Let's see. Oh, I gotta... Oh, there we go. Let's see. We have mod the cube. That's what I do with the previous ones. Hard to tell. Let's just do this then. Extract here. No Mac. Assets. Import package. Hey, I remembered. Guess it's not too hard. Okay, let's see. So, done. Before you begin editing the code, take a few minutes to understand what the script does by default. The imported package contains 3 items: a C# script, a material, and a scene. In the scene, enter play mode and observe the default behavior. You'll observe several of the cube's properties. Change. modify hub. Now let's see. Seams, sample seam? Or is that not it? Yeah, there we go. Mod the cube seam. Okay. Let's see. The cube has the cube material already. Let's take a look at the cube script. Okay, let's see. So, transform position equals new vector. Local scale vector. Sky material. Material color equals new. Transform rotate. So it's going to be. Let's take a look. Not 100%. Colored rotating. Oh, they made a great game, so applause. Now let's see, can I look at it? What the hell is it? Okay. This is rotating only along one axis here. It did change the color to green, which I'm assuming is based off of the color values here. Don't know these, but so it rotates. It sets, well, first it sets its position, it sets its scale, it finds its material and it changes the color, and then it just starts rotating the cube. Okay, should be pretty straightforward. Let's go check it back out in here. Modify the script. Okay, we can customize it. All of the changes the script is making to the cube are specified in the code. Be easier to control the cube from the Unity editor instead of editing the script. You can make this possible by changing the variables to be public. Right. Public variables appear in the inspector window. It's good to know. Public variables appear in the inspector window. That is a key takeaway. Open the cube script. Identify at least 2 changes you can make to its behavior. Okay. Change the cube's location, scale, angle at which it rotates, speed, cube's material color, cube's material opacity. I did notice that it was a little bit translucent seeming. Oh, also, I'm pretty sure it shoots it up here. Yeah, it does. It moves it up. Okay. So let's see. If you're feeling confident, you can attempt the following as well. Modify any of the changes above so they change randomly each time a scene is played. Add extra functionality to the cube. For example, how might you change the color of the cube over time? Implement your planned changes in the code. Test the scene. And then it's like, good luck, bud, you did it. So this looks like it's going to be a little bit more self-paced as opposed to it guiding through here. Let's see what we can do. So let's just take a second to check out the different transformations. So like it says, location, scale, angle, the speed is a little bit different, the material color, and the opacity, those are kind of the material properties. So let's check this out. Let's do Unity rotate objects. And it gives us a piece of rotation. It's got the old stuff in here. Okay, we could look more into that, but I think I'll pass for right now. So you can specify a rotation based off the world axis or a local axis. World axis rotation uses the coordinate system of the scene. So when you start to rotate a game object, they're aligned with the world axes. When you select a cube, view the rotation gizmos for the left, right, up, down, forward, and back rotation axes. Would restart in world alignment. Interesting. Local rotation uses the coordinate system of the game object itself. So a newly created cube uses its own X, Y, and Z axis set to 0 rotation. Rotating the cube updates the rotation axes. So, play a little bit of spot the difference here. Even though it's pretty clear the rotation of the object, but let's see. So we can see that it's got some different numbers in here that aren't 0. This might be because of the axes here. So if we look at it with the rotation, you can see Y changing. That's changing all of them, probably because it's doing multiple things at once. So we'll come back to that one. Well, that's doing it too. I guess it would have to be straight on the face for it to only do one at a time. So let's see, we've got the gizmos. Yeah, there's a lot of shit in there. Let's go back to what it said. Cube not rotated in global gizmo toggle. Did you give us the same example twice? Oh, one's local and one's global. Yeah, that makes sense. So let's see. We've got, let's compare the two, the local and the global for not rotated. I see this little button, so it says local and global. And I'm pretty sure that's you. Oh, there we go. So if I set this rotation to 0, and I guess this is kind of what I meant by it would need to rotate directly on the face. So now we've got a direct Z rotation. We've got a direct, ooh, that one's screwy. Yeah, now it's rotating the things individually. Let's just try setting all these to 0. So we can see what it does. Let's just go with 35 on the Y. Yeah, so we can see how it rotates. Oh, that was X. 35 on the Y. It's rotating around its local Y axis, which is the vertical. 35 on the Z. Okay, and so if we change it back to global, try 35 again. looks kind of the same so far. So let's do this. Shoot. I don't think they have the grid on, and I don't know how to turn it on right now, so let's just try this. Rotate you a little bit in a weird way. Yeah, you're crazy now. And we'll just move you over. So I think what we're supposed to see is yeah, that's it. Okay, so the global is saying, like, if there was a floor under here, you know, these axes are never going to change. So no matter what orientation it's in, the x-axis is always going to rotate it, you know, like this. So if I were to put another, that's a good example too. It snaps back. So even though I can rotate this, we can see the green line and the blue line for the x and z axes rotating with it. As soon as I let go, the object stays rotate, but the axes, they snap back. So the x-axis stays as x, the y stays as y, and the z stays as z. Whereas if I swap it over to local, it kind of looks like some energy company's logo or something like that. So now these can be rotated based on the orientation of the object itself. I see. So the next thing to take away from that is how to do that in code. Well, no, so that says that's in the scene view. So oh, I see. This one says if you deselect and reselect the cube, then it resets the orientation. But I guess that must have been updated because it kind of snapped back now. Very cool. So let's see what else it says. So in order to do this, our declaration is public void rotate. It needs a vector, and it says Euler's. And I guess that's what this is. A Euler angle, not a quaternion. I still don't want to delve into that, even though it seems useful for this. And then space relative to equals space dot self. Determines whether to rotate the object locally or relative to the scene in world space. So I have a feeling that that's the difference between the global and the local rotations. Applies a rotation of angles, degrees around the z-axis. Oh, I see. So it's just using .x, .y, and .z to specify. Well, that does say change the angle at which the cube rotates, so we're probably going to need this one. Wait, I'm sorry, that's the... It don't matter. Okay, and then this one is a little bit different. Rotate float angles. So it applies a rotation of a certain amount of degrees around the axes. Can have 3 floats specified. For example, show 2 cubes. One cube uses space self, and one uses space.world. Okay, that's good to know that that's the other, space self versus space.world. The space and axes in relation to scene. Okay, so that's how, if we were to use space.local, basically, set these to 0. Oops. Oops, oops, oops. If we were to use space.local and then set like 90 to rotate in script by... Okay, 90 is a really bad example because it's a cube, but if we were to use the space.local to change it by 45 degrees, it would snap over to this. Otherwise, if it was already rotated a bunch of times... 016, yeah. If it was already rotated a bunch of times and we were to use space.world, I guess I had a shitty example because I was already on global. Either way, if we were to use the global to change the degrees, regardless of what rotation it already had, it would go ahead and move it that way. So let's see what this script says. So this one's for position, this one's for rotation, this one's for material, this one's called self, and this one's called world. Add it onto any game object in a scene and hit play to see it run. The rotation is controlled using the angles modifiable on the inspector. And it's modifiable because these are public. So it just creates cubes for you. You really can just copy this whole thing. Well, let's try it. Add it onto any game object in this game. So let's see. We'll add it onto this. And we'll just stick it in here. Create a script. Oh, I forgot I was supposed to name it. That sucks. Actually, I don't really know that it matters. So, let's give her one of these. Double check. Void awake, void update. Okay, so it covers the whole thing. So we don't need to worry about all this. Just put this in here. Oh, it's called example script. Well... that back. Actually, we don't even need it. So we'll save this and let me temporarily turn this off and drop this one on. So let's see what happens first. There's my two created cubes. And they do nothing. Oh. So, they do not move currently, but you could set them to move. Let's do 30. Whoa! Bro's flying. Okay. I think the example here is to... Whoa. I don't know what I just clicked. I think I hit cut. I think the example here is to... Let's try 10. That doesn't make it any slower. Okay, we're going to use decimals. Okay. So it seems like the example that we want to use here is, since one is supposed to be local and one is supposed to be global, right? What's the script we just put in here? Space.world, space.self. Okay, so red is local, green is global. if we were to, well, let me try this way. If we were to set the X angle to constantly rotate by 0.1 degree, maybe, however that's supposed to do that, whatever, we can see that they're both rotating kind of as if there was a spike or an axis running through them this way. Now, since the red one is supposed to be local, it should only be rotating with these faces. So if we turn this, we can see that it's kind of going a different direction now than this one. So it's kind of cooked. So we put it back to 0. Whereas this one, it's always going to keep rotating that direction no matter what it's facing. So that's cool. What happens if we turn on multiple? Does it go crazy? Whoa. Is it even distinguishable? Give us some space here. So we can just pretty much fuck this thing up however we want. And it's just gonna keep on trucking. And this one, since it's always rotating on its faces, as opposed to on the axes, it acts a little bit differently. Although it's hard to tell with all three going at the same time. So, wait, did I? Oh, here, we'll just jump everything to 0 and see what keeps changing. There we go. So yeah. That's another good example. When I set everything to 0 here, since it's moving on its local axis, the X is the only one that's supposed to be changing, which it is currently. The other two are stationary. This one, if I were to go ahead and set these back to 0, it makes me look like a fool. Now, the example here is to set something else to 45. Just as an example, we'll say the X one is the only one that's constantly changing because that one's the local rotation. So this one, if we go ahead and apply something else in here, we can see that multiple of them start changing because it's rotating on a global axis as opposed to a local axis. I think that's the highlight there. And just for the sake of it, that script, this is to create the cube, same here. This is to color the cube, same here. But what we're doing is, this is setting a position, so we don't need to worry about these too much. But the line that we're really looking for is this cube.transform.rotate. Now, based off the code, I want to understand why these are set in here, 3 of them as floats. Oh, okay, this is why. Because public, float, X angle, Y angle, Z angle. So you're setting those in there. Okay, and the rotate needs the parameters, whatever's inside the parentheses, arguments, I think it's called. The rotate will need the arguments for in what ways it's rotating them. And so we're setting these in here. But since it's public, what am I trying to say? These are the ones that are actually updating. This is setting them static because it's awake. As soon as it creates them that way, it's setting them there. But the update X angle, Y angle, Z angle, public, float. Ah, okay. So, based off the documentation with the format of the command, where it's supposed to have these floats listed as numbers, um, it's replacing them with these words here, almost like variables, because it's setting the float as public so that they can be altered from within the inspector, which is this. Okay, I think I've got an understanding there. Okay, so this is a good example script. I like this. So let's apply it to our other guy. We can go ahead and stop, kill this. Actually, no. I don't want to delete it because it seems like it might be useful, but I will deactivate it. Actually, I'll just take it off of the script entirely. Or, sorry, the object entirely. Or will I? Remove component. Gosh. So, now let's go ahead and take a look at our regular cube script. So if we wanted to rotate it, I think, I mean, I don't want to just copy the line, but that's the line that we need. It's just this. We just have to change it a little bit. It's using delta time as a speed here. So here, let's just do this, so we can reference it immediately. So we don't need this because it's only applying to the game object that it's on, not the game object that it's creating. Transform.rotate, it's got angles in here. Okay, so it's trying to do these one at a time, and it's got the time delta time on it. Gosh, specifically for the X. So, yeah, let's do it the way that they do it here. So they declare the X angle, Y angle, Z angle in the class, but outside of these. So we'll just do the same thing. Public float. Press a bunch of buttons that we didn't know we pressed. Copy them X angle, Y angle, Z angle, thank you. And so what we're doing with this well, let's change it a little bit. Rotation. Since we're going to add more modifications, let's make it a bit more understandable by naming these totation. And what we need to do is sub these in down here. So this one's going to be X rotation. And I guess we can leave time delta time in there. Not 100% on the function of this at the moment, since it can do it without these, but we'll do Y rotation, and we'll do the same thing, times time dot, whoops, time dot delta time, and the last one, Z rotation, times time dot delta time. Okay, so this can go away. I think this makes sense. So let's save it. See if it yells at us. No issues. And now when we select this, we see that our cube script has the rotation set on them. So if we hit play, it should do nothing. Okay, yes, it's just a regular green square that's slightly see-through, noted. So let's play with these. So if we set X rotation 2.1, it's moving. Hell of a lot slower than the other ones, so let's just try 10. Hey, let's do 10 and 10. Yay, we've got a cube worth pondering. Could definitely contest with an orb. Just for the shit of it, let's do 15 and 20, so we have different rotations. Now it's rotating weird. But this is what we want. However, there is one more alteration that we can do here, and that's how we want it to rotate. Now, we didn't put the local or global in here, so it's left us another argument at the very end, space.self or space.world. Since it's doing it on its own, clicking all the wrong things, what's the default? Actually, we should be able to figure out what the default is just by checking it out here. So let's see, if we only set one of them, we'll do 15. We'll make sure all these rotations get set to 0. All of them, sir. Okay. All of these get set to 0. Press all the wrong buttons still. Save. Play. And we can see that only the X is rotating. So if I come into my scene view and I throw a wrench into it by rotating something. So with all the others staying stationary, like we saw before. Okay, we're gonna ignore that. That one was probably nothing, right? Right. So with these numbers staying stationary and only this X changing, despite me doing funky shit. No, so then it is global. So, and the way that we can double test this is in the script here. If we add one more space, by spelling it right, space dot self. That's what it is, not local. That's going to be a little annoying. Self and local are the same thing, but save this script. Come back in here. Play it one more time. And so now, if we throw a monkey wrench into it, start rotating random things. What? Now I'm confused, girl. I think I was trying to do too much, not gonna lie. Shoop. Well, it made sense before, but that fucked it up. Let's go ahead and sit back down. We're getting too high up there. So let's just keep reading now that we used this test script. So, oh yeah, that's right. There's also the one that's just a rotation, and then there's this one with a vector in it. Unless I'm misunderstanding the documentation. Are these just multiple ways to do the same thing? I think they are. I see. So this setup lets us specifically list the axis that we want to rotate on, and then the amount of rotation that we want to do, as well as the self or local or self or global. So it does seem like it's the same thing, different way to do the same thing. Now, okay, now this gets a little bit confusing because it's saying a lot of repeat things. I think it really is just different ways to do the same thing. So, switch to manual. Oh, go to transform component in the manual. Okay, so let me just compare some of these. Let's get a little list going. Oh, you know what? This white background makes it a little bit difficult. I'll try to fix that later. I think for now I'll just turn it off. Okay. So let's grab these so that we can look at all of them. So we've got this one. We've got this one. We've got this one. We got this one. Oops. One, two, three, 4, 5, 6. Okay, so let's look at all of them side by side. So what we're mostly interested in is the different arguments here. This one specifies vector 3 Eulers plus the space. So it's saying however you want to do the vector 3 Eulers, you can, plus the space. Oh, there's another thing that's interesting. So these bottom 3 are exclusive to self. Either that or it's saying that the way that this command is run makes itself by default. Because what I'm seeing is... Oh, gotcha. So these 3 are repeat commands of these. But what it's saying is that if you run it without the space definition inside of the arguments, it defaults to self. Which that does kind of answer my question from before. So, let's focus on these top 3, which is saying that you can specify the angles in 3 different ways. One is use the Eulers, one is use the angles as floats, and one is specify a specific axis, specify the angle. Interesting. I wish they had more example scripts for how to do these other types too, because I'm interested in the vector 3s. Rotate takes a vector 3 argument as an angle. Second argument is the axes, which can be set to local. This rotation is by Euler. Well, I want to see that, but here, what happens if I do this? Okay, takes vector 3, right, this is what we were looking at, and obviously the space enum, sure, enumerator, okay. Ah, okay. So, then if we apply this logic, what we should be able to do is, if we wanted, instead of doing this jazz, and this, and this, and this, we could replace it with vector 3. Well, no, wouldn't that just end up doing the same thing? Because wrong thing. See, this is an example. Sure, I see what's going on. Yeah. But this one doesn't have the order of rotation specified in the Eulers affects the final rotation. You can control the direction and speed of the rotation using the get axis. Understanding the difference between space and world, whatever. I say whatever as it says it's crucial. Weird. We'll chalk it up as weird, but I think this accomplishes one of our goals. So let's check this. So we've got the angle, or do we? Isn't that what this is? We're changing the angle. Let's see. So, applies a rotation of degrees around the axis. And since it's in the update function, I guess it's rotating based on the frames. So, does that count as the angle at which the cube rotates? Maybe. Let's move on to another one. Let's try cube scale. So, with this, we should be able to just find the scale. Scale. Can't find it. Can't find it. Let's see. Unity scale objects. Let's just try that one. How to change scale of objects in runtime. This is discussion. Okay, scale objects through script. I spelled through wrong. Transform dot local scale. Okay, let's see here. I think this will be helpful. Scale of the transform is relative to the object's parent. The example below creates a sphere with a scale. The application then changes the... I see. So it's just... Let's check this out. Okay, so let's do... I can't just leave this in here as new. We'll get rid of it. Let's take it out of here. Ah! We'll do this. It won't let me go back. Oh, it's cooked. Okay. So, do this. Wait, first let me double check this. Using public class cube. Okay. So let's make this one public class example. We'll change this to pressing all the wrong things. Create script. We're going to do this one as scalar. Scalar. Paste all and call this scalar. Save. We'll check this out. Oh shit, I just did that in the... Okay. Open this, please. Thank you. Just rewrote the cube one by accident. Oh wait, I need this to be called scalar. No issues, no issues. Minimize. Oh, our boy's still floating. Chilling to the lo-fi beats. So, let's see. We're gonna have to stop this so I can put that on here. In the scalar, we have no parameters that will change, so we run it. Oh wow, that is really fast. I also don't know what's up with the pink square. Let's check it out. Create sphere, create plane. I really don't give a shit about the plane, so it's supposed to change the color. I think I've seen this one before. Remembering it is going to be difficult. Ah, fuck it. Goodbye. Or... Womp. So we don't care about the floor. What we're looking for is... yeah, the local scale transformations. We'll hit save here and see if this yells at us. Stop. And start again. Well. Yeah, it's doing its thing. It scales slower when it's selected. It's kind of funny. It's kind of weird to just look at, but let's actually do something here. With the scaler, see, these say private. This is excessive, no? Okay, fine. It's creating it and it's setting it at 000. Now, it's a scale change. It's giving these numbers. So, let's check this. And so it says it changes it down to 0.25 and then back up. Oh, I see. Yeah. Well, we could probably change this a little bit. So, it scales off of vectors, which is a little bit confusing because when it scales, isn't it supposed to scale the whole thing? I guess it's just understanding the vector 3. So let's do it that way. Oh, that's right. These are helpful to know. Oh gosh. Creates a new vector with given components, blah blah blah. Okay, so let's try this. Private. Let's just do this. Change you to. Can we change you to public? You gonna yell at me? It doesn't. But I don't think it's done correctly. Because if I do this and come back over here, I don't think it's gonna let me specify each one. Oh, it does. Goat. I see. Well, that kind of teaches us something about the the rotation as well, because when you did it the way that I have it set in here, where I have each of these specified, it gives you 3 separate fields that you can change. Whereas if you do it through the vector 3, it just seems to know, so it has all 3 of them listed already. So then, just out of curiosity, you know what? We shouldn't get too ahead of ourselves. Let's finish the scaling, and then I want to go back to the rotation. So, scaling. Let's just set the defaults to... No. We'll leave it alone, because it's defaulting to shrinking the scale. And then once it gets down to a certain amount, it will go bigger, and then once it gets above that amount, it gets smaller again. So it just bounces between those. Scale change equals negative scale change. Ah, yeah. But it does the position change, which is interesting. We might have to toy with that a little bit just to see what the hell happens. Yeah, move upwards when the spear hits the floor, or downwards when the sphere scale extends. Holy shit. Sphere scale extends beyond one. Okay. So by making this public, this allows us to change it, but what does changing it do? We'll hit save here. And we'll hit play. And it's doing its little thing. So and that's interesting. Pause. What happens if we change it to 5? 5. 5. Does it go faster? Oh. Play. Yeah, it does. Let's go even slower if we can. 01? Does it accept that? It does. Oops. Oh, let's just keep going. Okay, let's try that. Oh, I think I understand the position thing now, because when it scales, it does some weird shit. You know, what if we just convince ourselves that, like, oh, the ball's falling really far and bouncing? Just, like, cope with that? No, because this is important. Because what happens if I start applying the scaling to my cube? Is it gonna do that? Does the position change not just seem weird? Do we need the position change? Can I just nix this entirely? Okay, what happens if I do that? Oh, it's goofy as fuck. No, it doesn't need the position change. I see how we can do those things together, which is important because that's what the guide is suggesting. But if I now come in here and I'll just throw an extra 0 in here and on you and play. Wow, look at her go. She's not spasming. Okay. So, the things that we should understand off of this specifically is adjusting the scaling here, which, so this is or creating it, and then this is setting the changes to go. But what we're doing, and I should have gotten rid of this before. Now, what is plus equals? I haven't seen this before. What is plus equals? So what happens if I... Okay, I should have known that. What happens if I do this? I think the plus is constantly modifying it. Because, yeah, I think if it was just equals, it would just be setting it to that. Well, I think that could be useful in its own right. Let's see. Save this. See what happens. Play. Oh, it doesn't exist. It doesn't exist. Well, I killed the ball. It was nice while it lasted. Huh. Is what's happening that it's too small to see? What if I change it to larger decimals? Well, it exists again. And so, yes, it does have its own right. God, I keep clicking on all the wrong shit. It does have its own use. So this could be used to force a scaling to it so that it doesn't just bounce like that. Hmm. Okay. I think I understand. And because it was set to 0.01, it was doing the constant spasming with the changing to the negative and the positive, which I don't think was doing anything, but it made it look like it didn't exist, which was kind of funny. So let's see. Well, what does this want us to do? It just says change the scale. What do we want to do with it? Probably... I think I'm thinking too complicated here, because I'm thinking about making like a UI almost, where it's like turn on some toggles, or, you know, a scaler to actually change the scale of the cube. You know what? For now, let's just go with the old bounce. Let's not let it get so small. Let's do 0.5. And yeah, so the other thing is, if we were going to set a stationary, we probably wouldn't put it inside of update, because that would be making it check constantly. So let's update this so that it says adjust the scale of the object and keep it within a range of size. Now, the things that we have to do, we'll save this. The things that we have to do to apply this to our cube here can I pull this out? No? Can I put two scripts on my screen? Maybe, but I don't know how. Let's try this. We're gonna want to... We need the actual scaling, which can be done by this, but not the sphere part. So let's see. Not capital. Transform dot. Wait. Local scale? Yes. Transform dot local scale. We need to set it as our vector 3. We'll come back to that. So, here's the other thing that I wanted to do. I wanted to check and see. No, that doesn't want to do it the way that I want it to. I'll have to figure that one out. So let's see. Local scale. Let's just 0, 0, 0. No, it still isn't like that. Something about the local scale fucks it. So what is different here besides this? Would it be... Because this seems to have no problem. So I would think that this would have no problem, but... Hey. Since we're in a local scale. Was this in the default script? Oh, it was setting the scale. Huh. Let's check the Google machine. And you know what? This one's local scale. Is there a global scale? Unity transform dot scale. It's just a scale. Local scale. Scale. Is there a? Let's try it. Global scale. Reading and setting an object's global scale. Lossy scale. Is that it? I don't think so. All right. Too deep down a different rabbit hole. Let's look at something else. Scale through script. Let's see what this discussion says. New to Unity. Want to change the scale during runtime of game object. How can I do that? I've used local scale function, but it didn't work properly. Maybe I didn't use it properly anyhow. Just check in with local scale. Okay. unfortunately, this isn't making a lot of sense to me. A YouTube video. I figured. How old is this? 2017? Ah, it's just 8 years old, you know? That's an interesting name, too, but, shit, let's try YouTube. Unity, scale, objects, scope. Objects. What is transform? Oh boy, there's a whole video on it. 6 years ago. Well, let's check out a video.
Actors.
Oh,
We can
boy.
make you believe we know what we're doing, when in fact, we do not.
Hello and welcome, I'm your Code Monkey, and in this video we're going to learn what a transform is and what it's used for. Let's begin. So, a transform is the main way to move, rotate, and scale game objects in your scene. Every game object has a transform by default. Let's go in the scene hierarchy in here and create a new game object. Here in the inspector, you can see it automatically added the transform component. Every game object always has a transform component. Here you can see the three main values for the transform: the position, the rotation, and the scale. They are represented as a vector 3, so they have an X, a Y, and a Z value. Let's add a sprite renderer so we can see the result of modifying the transform. So add component, sprite, renderer. I'm going to drag this sprite in here so we can see visually our game object. So here's the sprite, and up here I can change the transform. Changing the position will move the sprite on the x-axis. I can change it on the y-axis.
Okay, that's cool though. He's grabbing those and doing it and just moving it back. Oh my God! We've left the ball seizing. It's absolutely tweaking. What has happened to you? Okay, I'm gonna put a stop to that. But he did a cool thing. Oh no shit. He just ooh, that's a neat little trick. I like that. Okay, good to know. No, I don't think we do want that there. Let's do 4, 4, 5. Okay, so you can move, in addition to moving it by using the actual colored sliders while having the game object selected with the move tool, you can let's say I have rotate selected. Oh man, is that useful. Okay, that's a good trick to know. You can move game objects by clicking on their desired axis and dragging left and right. Can I change the rotation too? That's wild. It's slow, but I can. You can probably see my mouse going like a carousel. It's funny. And can we do scale the same way? That's wild, dude. That's so cool. Okay, good feature, good feature. Glad we learned that. Let's check this out.
I have this scene set up in 2D. You normally would not modify the Z-axis since that would be towards and away from the camera. So
yeah, I think it's interesting that he's using a sprite here as opposed to a 3D object, because I feel like scale is, I mean, it's just more, I don't want to say more intuitive, but I mean, I guess you could do scale with 2D. Let's just see, let me just watch the video.
Leave this at 0. I can also rotate my sprite. However, again, since this is in 2D, you normally would only rotate the Z-axis, which would provide that rotation. The X and Y would apply some rotation that is only applicable in a 3D environment. The scale modifies the size of the game object. Using a sprite renderer means that the size of this object that you can see in here is dependent on the settings of the sprite when imported. So in here, as you can see, this spaceship sprite has a size of 64 by 64, and in pixels per unit, I've selected 64. That means 64 pixels in this texture will equal 1 unit in game. So as you can see, this texture is 64 by 64. Using 64 pixels per unit means that the sprite by default will be 1 by 1.
Okay, I know this is besides the point, but that seems like something that's good to know too, because I did intend to make some 2D games, at least for practice. So the pixels per unit Sounds like basically a way to translate some sizes. Sounds useful.
As you can see the size, it is in 1x1 unit right there.
Yeah,
And
how
if
about
I
that?
modify the scale, it will modify according to that sprite scale. So I can modify the X, I can modify the Y, and again I can modify the Z, but since this isn't 2D, let's leave that at 1. One more thing that is related to transforms and the sprites is when you import a sprite, you can modify the pivot. The pivot will affect how
That's
the sprite
awesome.
rotates. So by default, it's in the center, but let's say I would
What
put
was
the
it that he
pivot
clicked
back
on?
here, hit apply, and now if I rotate on the output, the sprites at 1. One more thing that is related to transforms and the sprites is when you import a sprite, you can modify the
Oh, there's a drop down that says pivot.
The pivot will affect how the sprite rotates. So by default, it's in the center, but let's say I would put the pivot back here, hit apply, and now if I rotate on the Z-axis, you can see that it rotated around that pivot. Okay, so that's movement, rotation, and scale of a single transform. You can also parent various transforms. So let's go in our hierarchy and duplicate our current game object. And let's make the second one a child of the first game object. Move it to the side so you can see it. So this in here, let me 10 so you can
Yeah, you know, I've seen that phrasing with the parent and the child. I only kind of understand it. I assume child is obviously linked to the parent, but I saw a lot of these things here in the documentation that we're reading saying something about how it affects a child when you're affecting a parent.
Game object. Now when I modify the parent, you can see that those changes are also applied to the child. So if I move, both of them move. If I rotate, both of them rotate.
I see.
And if I scale, both of them scale. On the inspector, what you see are the local transform values and not the global values.
Oh, because it's inside of the main game object. Okay, I understand.
Here are represented in the local position space. So let's put this one on 1 and 0. If I put my parent on 2, 0, then the world position of this one is on 3, 0, but it shows 1, 0. Again, this is the local and not the global position.
So you're basically choosing relative spacing to the parent.
Space is very important to fully understand. The same thing is applied to the rotation and scale. What you see here are the local values, and if you apply them outside, you will still see the local values in here. Alright, so that's what we can do with a transform from the editor. Now let's write some code. Let's make a new C# script and let's name it transform test. We're going to add this script to the parent transform, and let's rename this to sprite and here a child transform, just to have more proper names to deal through code. With our script running on the parent, let's go into the code.
Oh, no, I'm yawning so much. Okay, let me get it together.
Transform. So let's make a debug.log of the transform and see if it correctly prints out our transform object. Yep, in the console, as you can see, our current transform has the name of sprite and it is of type unityengine.transform. So let's modify the transform position. We do that by going into the transform.position, which will set the transform global position, and we're going to put it on vector 3, let's say 1, 0, 0. So as you can see, our transform is on 2, 0, 0, and if we run the code,
it's going to jump it to 1.
You can see that it was repositioned to 1, 0, 0. So now let's move our transform on update. So let's
gotta lock in.
And we're
gotta
going
lock
to set
in.
our transform.position to transform.position plus a new vector 3 of, let's say, 0.01 per frame. So essentially every single frame we're going to move this transform 0.01 to the right side, since we are moving on the x-axis in here. So let's test. Yep, there you go. As you can see, the spaceship is moving and the child game object, as you can see, is moving with it.
Right.
Now, there are many ways to rotate a transform depending on if you're working in 2D or 3D. For me, since I work in 2D, the easiest way is to modify transform.Euler angles. So let's do a transform.Euler angles, which again are represented as a new vector 3. And again, if you remember, in 2D, we only want to modify the Z value. So let's do the same thing we did previously and increase the Euler angles by 0.1f every frame. So this should make our sprite rotate continuously. Yep, as you can see, the sprite is rotating on the Z axis. So finally, we can modify the scale of our transform by going to transform.localScale, and we're going to do the same thing, set the local scale to local scale plus a vector 3, and let's increase by 0.01, 0.01 also on the y, and 0 on the z. So this should increase the size of our transform whilst maintaining the aspect ratio. Yep, there you go, you can see the scale increasing per frame. So now we have a sprite that is changing position, moving to the right side, changing rotation by rotating, and also changing the scale. Those are the three main properties of a transform. So all these values that you see in here are global values. There is a second set of variables to handle local values. For position, instead of transform.position, you have transform.local position. For the rotation, you have local Euler angles or local rotation if you want to deal with quaternions. And for the local scale, you have the local scale. So as we saw previously, the inspector displays the local values of that transform. On the child in here, you can see the local position. It is on 1, 0, 0. And we can see that through code. Let's go into our start. And first of all, in order to access the transform of the child, we use transform.find. And then we find the name of our transform, which in this case, child transform. This is the reference to our child transform. So now with that child transform, let's print out the local and global position. So let's do a debug.log of the local position, which should display exactly the same as we see in the inspector, and the position, which should show something different. And let's stop moving the parent on start. All right, so let's see what these two values.
So, gotta break this down because there's actually a lot of information that was just packed into that little segment there. One is he went over the transformation changes, which is based off of those basic aspects of the transform component. So he did the position, the angles, and the scale. The other thing that he did was, which this is unrelated to what I'm trying to do at the moment, but it's still useful. He used this transform a little bit differently. I see that it's different, one, because it has the capital. It also changed colors, but I'm not 100% on this. I think it's saying that it's the component, like this component. Maybe. Still cool. Let me finish the rest of this.
Displaying. As you can see in the console, the local value is 100, but the global value is 300. So the local matches what you see in the inspector, but the global is different. If we were to set the parent to 000, then the local would be the same as the global. So there you have it. We covered what is a transform and all the ways we can modify it both in the editor.
All right, thanks, bud. Let's see what we can figure out. So the other thing that I learned is, see, this is a little bit different because he was doing his by setting them equal. Let me bring his portion back up with all of that. Oh, most replayed, big shock. Yeah, because he's setting his equal, even if he's doing Euler angles. What are we doing? Just transform.rotate. Is this related to this guy? Maybe not. So transform dot local scale equals. Hey, would you look at that? It's actually letting us do a thing. So if we copy, that's so strange. Transform.localScale equals transform.localScale plus other stuff. I mean, I guess it makes sense, but how does this one do it? Scale change. Where is it setting it that way, though? Oh, sphere.transform.localScale plus scale change. But it's setting it equal right here. Okay, so that should have been. We'll look at that in a second. So for right now, let's focus on. So it set it in here as this. Can I do this? Public. Public. Oh, they did vector 3 with a capital. Public vector 3 equals. No equals. Public vector 3 scale. No, not a capital. Scale change. Bunk. No. Bunk. Yes. So what I'm doing is declaring it as public so that it can be changed in the Unity inspector. We're initializing it there because it's called scale change. We want to do in here, we'll group these material ones together. Scale change equals. So it's going to be vector 3. What is dot 1? Oh. That makes a lot of sense. But I don't think I want to do that right now. It was new, right? New, vector 3, not the dot. Does it need the parentheses? Ah, Christ. Parentheses. We'll just do 0, 0, 0. Actually, it would probably be best to leave it at 1, 1, 1. So the transform.localScale equals transform.localScale scale change. No, it doesn't like that. Non-invocable member transform.localScale cannot be used like a method. Okay, what do we do here? Equals. Oh, it's just literally setting it that way. What am I thinking of then? Where did I pull this from? Maybe I pulled it from this. So then, scale change. That works. However, this would probably set it statically. So we'll just give this a try here. Save, go away, you go away too. Oopsie. Scalar, scale change. So if I do 1, 1, 1, play. And we're not actually paying attention to the ball this time. Are we? No, because we're looking at this one. We should be looking at this one. Play. So if I do 2, 2, 2. So yes, the answer is yes, it is static. We're going to go ahead and turn you off, buddy. Okay. So it is static. If we want it to do like the ball was doing, we're probably going to need to put this if statement in here. We'll just have to tweak her a little bit and adjust the scale of the object and keep it within a range of size. So this is going to be if it's going to pulse. So we want to, if transform.local scale is bigger than 5, and if it is, wait, I know what this is. I wrote it down. Or, it's or. Got it. It makes sense. If the local scale is smaller than 0.5, or if it's larger than 1, we'll do 2, not 20, 2, just 2. Then it's going to flip the scale change. So, but the other thing is, it had the plus equals. And I learned that taking away the plus takes away the motion of it. So, no. Pressing the wrong buttons. I'm pressing all the wrong buttons. Plus, so, okay. So let's do it like this because just for the purposes of putting all the modifications on screen, I want to do the little scaling. So we save the script, let's go back to Unity, and let's hit play. Oh, it's seizing. I thought I thought I turned you off. Go away. Get out of here. Get out of here. And now it's like, wow. That's kind of impressive. Okay. Chill the fuck out. Hi. Scared the hell out of me. I thought I was all by myself. I don't know that I can. Yeah, definitely new to streaming. Well, yeah, maybe if I use the floats and use smaller numbers, that will make it less less horrible. F. I gotta do the zeros. Maybe that will make it less abrupt. So let me get rid of that. Okay, now let's try it. Is it going to be so spasmy? No, it's still quick, but not as fast as it was before. So it says 0.1 in here. Can I just go ahead and can you read my chat? Yeah. Do I plan to stream daily? Yeah, the intention is to be almost daily. Um, wow, I said kind of twice. I was going to use it as it's supposed to be a late night thing, but I'm currently off from work for the next 2 weeks. So I was going to do it in the day, kind of to like maybe gather some folks who might be interested, and then start my actual stream schedule. And I was going to adjust my stream to reflect that schedule too. Okay, let's see. Hey, that's way more manageable. Still pretty quick, but I think I got it. So, we'll just go ahead and set that as a default. 0.01, 0.01, 0.01, and yeah, let's just Save. Okay, so what I did to put that in here is I publicly declared scale change as a vector 3. Thanks for the follow. Hopefully I'll see you around. Okay, what games am I into? Oh boy. Well, here, let's see. This is my desktop. That probably explains it a lot better than I can. Um, we'll say mostly single player games because I'm pretty bad at most of the multiplayer games, or at least the competitive ones. Don't worry about this. Nobody's worried about that ever. Um, these are probably my more favorite games. RPGs, I guess. I kind of like those. Risk of Rain's a really good game, though. I don't, I'm not intending to play them super often on stream just because I'm trying to mostly use the stream time as an opportunity to learn and teach what I'm learning. Um, but I definitely do intend to play some games for that same purpose, though, to teach and learn. Okay, so let's check. Got another one checked off the list here. Change the cube's location. This one I feel like I should be able to do on my own, but it's also literally right here. So we're going to cheat a little bit. Next, transform dot translate, if I can spell it right. Did I? That's position. I'm thinking of the actual mathematical. DBD? Dead by Daylight. Okay. Yeah, one of my friends is really big on Valorant. I just not very good at it. PUBG. Man, I feel like I haven't heard of people playing PUBG in a really long time. It's mostly Fortnite now. Let's do public. You do art. What kind of art are you into? Is it like digital or do you draw? So this one's a vector 3 also. Transform position equals new vector 3. Okay, so I think it's kind of the same. Oh boy, I'll have to check out my stream delay too. Um, Scale change, position change. Let's go with that. Digital, yeah, cool. Would you like to see? Yeah, sure. We can look at it. Do you do like logos, or like is it graphic design, or is it just art? That's probably a pretty uneducated question, but and now I want to call these rotation change. Okay, so what I was doing is I'm creating those as floats. How did I set them? I didn't. All I did was put them in. Maybe I should try to do this a little more uniform then. So let's see. Public vector 3. We're going to call this one, shit, what are the other ones called? Yeah, rotation change. So yeah, now these ones make no sense. Let's do this over. Let's do this one over. Transform dot. I do have Discord. I guess I probably should have set that one up. It's just a private right now, but let's see. Yes, my Instagram should be linked. It should be in the description of my stream. Okay, sure. Position change and position dot rotation. Nice. Equals rotation change. Now, what isn't right about this? Oh boy. This is why I shouldn't mess up what's already working. Let's see, let's take a second to look at Discord. Haven't added a friend in so long. Uh, oh, how about this? Does that work? No? Amateur hours out here. And I'm pressing all the wrong buttons. Add friend. It's a giant button. My God. There we go. Okay. So while I'm doing this, let me look at Unity transform dot rotation. Oh, this one is only quaternion. It's not vector 3. Okay, I understand. Let's see. Yeah, neat. Oh, of course we've got Espeon in there. Yeah, these are cool. Okay, so it stores the rotation in the world space. Oh, you know what? I see. So we're doing these a little bit differently. I probably should have commented it out before I just deleted it before. Let me run that back. Yeah, there we go. So this is doing a rotation as opposed to setting the position. It's a little bit different, or excuse me, as opposed to setting it. I'll get rid of this. No, wait, I did want that. No, I did not want that. I want position change. So this is position change, not Chagny. Position change. Hmm, maybe I'm going about this wrong. What am I not understanding? Just not focused. Rotate a game object using a quaternion. This example script lets you put an input in to turn it. Okay, to transfer it using Euler angles, transform.rotate. Right, and this is the one that I was reading before. So, can I do... Let me pull up the scale again. Tran unity dot no transform dot local scale. Check this. It seems like these work a little fundamentally differently. I don't think I can apply the same logic to each single one. So in that case, I think the rotation is probably fine as it is, and the local scale is fine as it is. But let me go ahead and focus separately on the position. What am I thinking? How should I move this? Maybe I should make it like fly around in a circle while it's rotating and shrinking. Seems like like sensory overload, but well, let me see what it looks like by default. So far we've got the, oh gosh, the super scaling. I thought I said it. Yeah, it says 0.01. Mm, that's a bit different. I might have to figure out how. I bet it's in here. Yeah, it's this. Okay. So we'll set these by default so that it stops tweaking out. Um, let's try again. Now it should be much slower. Yes. So what we can do next is these rotations. Let's try 10, 10, and 10. So we've got a rotating, pulsing cube. That's something. Okay, so we'll stop here. And then I need to do the same thing where so this transform position sets it to a starter location. This scale sets it to a starter scale. This defines the scale change variable. The rotations are never defined because they're supposed to be defined in the inspector. But if I was to define each single one as a way to set it to a default, can I set all of them at the same time? Looks like it. Let's try it. Save, minimize, and run this here. It's not rotating. Okay, let me go back to this. And what is with the time delta time? It's because it's supposed to do it. Maybe I should come back to that. I'm getting too off track. Let's go ahead and do this. Let's set position change to, let's see, if we wanted to, I don't think I'm going to be able to get it to go in a circle. So I don't think I could figure that out on my own. Let's just do something similar to how we did the scale. Let's go with 1, 0, 0. Finish that line. And we'll do this. Transform dot No, we've already got the transform position equals position change. And let's do it kind of the same way that we've got this. So if transform dot position dot, we did x, is let's then we'll say 1. Or transform position is greater than 5. Bracket. Yeah, that should work. Let's see if that does what I want it to. And this didn't really work, so I'll just leave it out. Let's let it save. Let's reselect this, and let's just set these to 10, 10, 10, save, and position change 1. Save. Play. Okay, it's rotating, but I don't see it moving. Oh. Hmm. Is that what I didn't do? No, I set it there. Maybe it's got to be a float. Maybe that's what I did wrong. 1.0 float. 0.0 float. 0.0 float. Will that do it? I don't think so, but I guess we'll see. Play. It's not moving. Mm. Oh. Maybe that's something that's happening. Is it because there's 2? So at the start, it sets it to this, and then it also sets it to this, but I would think that would be working. Why does this need to be a vector? No, because it's still describing a point. I guess I don't need this. Transform to local scale. I see it's setting the scale. No, I don't need that. Hmm. Yeah, let's just see what happens with these changes. So it still sets the color and the opacity. It's got the scaling, which seems to be working just fine. Stop. Can I do this even slower, just so it's not so eye torture? Save. Oh, maybe it can't go much slower. Well, it's in there. Well, let's try this too. Try 10. See what happens. Gosh, it really doesn't like it. No. One thing at a time. Hey, look at that. It's reasonable. Maybe it needs to be changed in here. Yeah, probably. Okay. So the other thing that I need to figure out here is this. What if I throw in 10? It moves it, and it's doing something. So it moves it when I put it in there, and it knows to flip it to the negative, but it's not actually moving. So times time dot delta time. What about this? Public float position change speed. Ugh, keep pressing the damn button. Times time delta time times position change speed. What about that? I need to save. Does it just pop up here? No. Maybe. Yes, position change speed. We'll set it to 1 and play. It might be messed up because it's at 10. We'll go back to 1. Play. It's spasming between 1 and -1. Huh. Okay, this one is stumping me a little bit, which is annoying because it seems so basic. Let's see. What did I miss here? I see as this transform dot position equals. Oh, maybe that's it. Transform it needs its current position plus the position change over the speed. Let's see. And then you know what? That would also allow it to be done off of wherever else. Let's make this range a little bit bigger just so I can see. Save. Position speed change, we'll do 1. And position change, we're going to set this to 1. Save. So it should be going across the X until it gets to 10, then come back, while also rotating and pulsing. Hey, success! So it did need the current position. Okay, that's good to remember. It needs its current, it needs a reference as to where it is so that the missile knows where it isn't. Nice, nice game. Okay, I probably need to adjust my camera. I guess I see why it's not working. Here, we'll do one of these guys. Whomp. And what happens when this is at 1? And when it's at 10? Is it all in the camera? Seems like it. Check game. Nice. Save. Play. It's working. Yo, this reminds me of some of those old dumbass screensavers. Oh, your boy got an idea. Oh yeah, your boy got an idea. I will, however, have to do it in a moment because I need to use the restroom. Be right back. All right, we are so back. So, let's get back to this. know what, I did like this video, so we're gonna hit like here, and we'll give this guy a sub because I think he can help us in the future. So I'm gonna close out of that, and now we've got 3 of these done. Location, scale, and rotation. We can do rotation speed real quick, and then next is going to be material changes, so the color and opacity. So we've got we've got the position change speed. Let's make another one. Public float. We'll do, bro, it knows rotation change speed. That's crazy. So we're not going to bother to initialize that because we can set it in the inspector, but I do want to put it in here as a multiplier. Yes, rotation change speed. Rotation change speed. Rotation change speed. So we'll save this. And over here, we are going to set the rotation change speed. You know what? This isn't so bad. Let me go ahead and just set these to 1. And let's set the rotation speed to 10 and see what happens to it. So now everything is just 1s and a singular 10, so that's funny. Save, play. Yeah, okay, so it rotates about the same speed, so I see what's going on there. So let's do this. Let's... Huh. I think this is playing with my mind a little bit here, because it looked like it was going up and down too, but let's do this. I'm gonna pop out the game window while I play with this. Let's find out the bounds. Oh boy. Yeah, this might get a little bit complicated here. Let's go back to the scene. And shoot, this is gonna be a little bit complicated just because it's on an angle like this. Well, let's try this then. Camera. You know what? I think we need a background. So let's do that. We'll create a new plane. We want our plane to have the same angle as the camera here. So let's see, because we want it to look flat. Copy, 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 paste. And now I see a new issue. It matches the rotation, but not the way that I thought it would, so it would appear completely flat. So all that means is we just need to alter this by 90 degrees. So instead of 36, let's try 126. Perfect. And now what we'll do is we'll put our cube at, you know what, let's do this. Let's say 5. Since 5 is moving back, and, oh, shit. Oh, 1 is farther away than the camera. So what's 10? Oh, 10 is all the way up by the camera. I see. Then let's try this. Camera, we'll look at game view. We'll click the cube, and we'll try to set this to 20. No, way too far. 10. 15. Okay, so Okay. So let's see. Our bounds is about 6.28. So let's do this. Let's do this. How about this? Public float. We'll do X position upper bound. Quite a mouthful. Perfect. I knew it would predict. And then public float. Oh man, look at this. It's just making it easy for me. Although that prediction is a little scary. So we're gonna go ahead and set all of these as public variables so that I can do it right there in the inspector. Save. And then we're gonna change this to if transform.local scale, no, we'll leave the scale alone. We need to do the position, and we're gonna need 3 of these. I hope having that many if statements isn't too tacky. But now we're going to change this one to Y. And we're going to change this one to Y. And we're going to change this one to Z. And we're going to change this one to Z. So. And then what we're going to do is instead of using actual numbers in here, we are going to replace this with our bound words. So, if the position of X is less than the... No. We want to do these first. Is less than the X position upper bound. Is less than the Y position upper bound. Sorry, this is greater than. And it's greater than the Z position upper bound. And then we grab the position lower bound and set this on this side. X, Y, Z. Okay, so what we've done in total is this. Just now, is we've created these variables called the X, Y, and Z position upper bound and position lower bound. What the intention for this is, as opposed to using in these if statements, whenever it gets to be above or below that upper or lower bound, respectively, I think I said it in the right order, it'll change directions. Because what we're going for here is, if you remember those really old, stupid screensavers where things would like bounce on the corners at the edge and everybody would shit their pants whenever it touched the top corner. And anyway, we're trying to make one of those, but we're going to do that with all of the instructions here with changing the location, the scale, the rotation, the speed, and we can do colors too. So we've done all this in code. We're setting our bounds. Actually, what we did is create the bounds, but now we have to do a little bit of testing with the object itself to see where it's at. Although I think I just hurt my brain a little bit by thinking too hard. So let's see. Oh, it's game view. No, I need game view. Cube. So how are we going to go up? Yeah. Oh, see, this is cursed because it's not a 2D plane. Oh, what am I doing? Oh, this is definitely cursed. Yeah, okay. I don't think I can do this 3D because it just doesn't math out in my brain. So let's do this. We'll reset the rotations of the camera. We're gonna also set the camera at zeros, just for simplicity's sake. And fuck it. Okay, so just for simplicity's sake, we've got our camera. We need my plane. I'm also going to reset the rotations for the plane. And we'll put it at zeros. Okay, so now of note, the plane needs to be 90 degrees on the X because that's the direction that the camera is facing. And now I'm going to back that ass up. 10? Oh, no. That's horrible. Negative 50. Oh, that's rotation. Negative 50? That's Y. Wow, guys, I'm doing everything wrong. Negative 50. Still wrong. Negative 50. Okay, positive 50. There we go. 80th time is the charm. So let's take our camera and our game view. Why is my plane not visible? Because it has no material. We'll do this. We'll just put cube material on it. Or apparently, the fuck we will. Plane. Materials. Let's just do ground. Dude, why doesn't it like this? Can I see it now? No. Oh, that was the wrong button, wasn't it? Definitely. Okay, let's try white. Okay, I don't know what's going on here. Let me kill the plane. And instead, we'll do a new, I guess, cube. And just scale it up. This is stupid. There's no reason for this. Oh, yeah, I guess you can't set things to 0. It's fucked up. What is going on? Okay. Sure, that's great. You know, we only need this on like 1. So, how's it look in the camera? Hey. How about that? It's a gray background. Wonderful. Cube 1. We're gonna call this background. And let me give it something. Will you actually accept white this time? Wonderful. Next, cube. Where are you, cube? So we're gonna set you to 0, 0, 0, and then add, we'll say 10. So game view. Back to cube. We're gonna set our rotations to 0. Okay, so I unintentionally made it invisible. What's this? Ground. How about now? Yay! Wonderful. Now let's check this out. So in the camera view, RX bound. Yeah, this gets really complicated because where should it bounce? I'm sure there's some thing that I'm not seeing. This is a work in progress, okay? So we'll just call it a work in progress. Step 1. We got to define the bounds. So our X position lower bound is going to be minus 9.25, while our X upper bound is going to be, oh, that's awesome, 9.26. We'll just also set it to 9.25. So now, our y upper bound, 4.98. We'll just go with 5. And if luck would have it, -5. So pog. And z, yeah, we're not going to worry about z. So 0. Shit. 10. That was what it was set to, right? It's 10. Okay, so we're not going to touch z. But I'm thinking. So we're going to nix the z's. And let's see, we set the rotation change speed. Yeah, we put it in here. Okay. So at the start, what we want to do is transform dot position equals vector 3 space 0, 0, 10. God, my spelling, dude. Transform equals new vector 3. Excellent. So this should force it to 0, 0, 10, which is just dead center. So with this, we want it to move all around. We want it to pulse with the scaling. We want it to rotate in all random directions. Save this so that it takes the z bounds out of my thingy. Okay, and try now. Let's increase the speed. We'll go 4. Bonk. Yeah, so when the scale is down, it bonks weird compared to... Oh. Okay, so it's just moving side to side. We'll put this on testing speed. We'll call it 5. Now, what I also need is... position change to 1 on the X and the Y. That should be the only thing that I have to change because I already have the transform position in here. And I just need to adjust the position change. So let's try that. That should be the only thing that needs to adjust. So we'll hit save and... something looks funky. It's doing it in a diagonal. Isn't it supposed to... You know what? I think I know what it is. I think it shouldn't be flipped to a negative because that would make sense why it just runs on the diagonal like that. Okay, I'm a little stumped right now. We'll go back to it because I want to go to the next goal, which is to change the cube's material color and its opacity. So what I'm guessing that we have to do is access a property of the cube, which is probably its material. So what happens if we... It's not going to be transform, is it? I think this is a Googler. Adjust material color. Wait. Oh. Material.setColor. Sometimes it's just that easy, I guess. So let's see. This one says public void set color string name color value, or public void set color integer name ID and color value. So I don't know these color values. Color property names are defined in the properties section of the shader code. Here are examples. Color, the main color of the material. You can access the shader property via the color property. So what? Oh, wait, it's already in the script a little bit. I should be able to mirror that. Yeah, material.color. So material.color, not capital M, right? Material? What doesn't it like? The name material does not exist in the current context. Okay. It is a capital M. Material. Wait. Oh. Oh my. Okay. Change color material. Unity. Script. I mean, I feel like it should be this, but because where is it using the material? Cube renderer.material.setColor. Okay. So this is creating the cube. Get the renderer component from the new cube. What does this look like in Unity? The renderer component. I mean, it must be this. Can I think these are details about the materials itself. Is it this? The shader? Is that what the renderer is? Okay, so not material. Shit. What the hell was it? Variable cube renderer. Bar? Cube renderer equals cube dot get component dot renderer. So can I just do get component dot render? See, this says mesh renderer. Is that what I'm looking for? Also, I think that probably shouldn't be in the update, so that's probably why it was having a problem. Public mesh renderer. Well, you know what? How about this? What is this? Well, I see what it's after, but it's get the renderer component from the new cube. Variable cube renderer equals cube.getComponent renderer. Use set color. So let's say that this is the renderer that it's trying to say. This says material equals renderer.material. So I think this is what we're going for here. We probably want material dot color, not capital. No, wait, this is how it equals new. Can it not do it in update? Do I gotta do renderer dot material dot color? Okay, it seemed to take that. Okay, so let me just take these values because I assume these values give it that green color, and let's just tweak it. We'll add 2, we'll take away 1, we'll add 3, and take away 2. See what the hell happens to that. Wait, isn't this just gonna be spasming through colors though? Let's see. Cube mesh render. Oh shit. Render is just cube mesh render. It's this. Ah. I see. So, public mesh renderer. For some reason, I forgot. This is declaring it as a variable, or at the very least as a component name. When we go and look inside of Unity, and here it is, the renderer that is the same one from the script, it says cube mesh renderer. This is where we got the opportunity to pick what renderer we were trying to use, which is right up here. It's this mesh renderer, the mesh renderer of the cube object that is currently set, which can then reference the material inside of it, which is currently called cube material. But the cube material has a property that's a color, probably somewhere. that it changes. So if I hit play, is it going to rapidly cycle through colors? No. Oh, we broke the cube a little bit. Oh boy. So I know what needs to happen. It shouldn't flip it. It should pick a new random number. Anyway, that's besides the point. That's not the color. Man, I keep just like a metronome, bouncing back and forth. So I have a feeling that this is not correct then. Render.material.color. What's happening here? The material class. Local variable material is renderer.material. Material.color. I don't understand though. That should have been everything then, right? Because it's saying the same thing. Renderer.material.color equals new color, this thing. Unless I've got the numbers messed up. Wait. I think that is wrong. So what if we do this? Renderer.material.setColor? No. It doesn't like that at all. It said, fuck you. Is it because of the cap? No cap. Set color. Now it doesn't like the whole thing. Is it just because this is messed up? Let's see what's something that's supposed to go in there. This. Let's just strip it. Ah. Okay. Let's see. Dude set it to red. Progress. So, this is how we're using this. Renderer.material.setColor, and then it has its own thing. You don't set it equal to something, you just change it in there. This is probably because we're not... The reason you would set it equal to something is because you would set a variable equal to it, and this isn't a variable, this is just making a change. So, what would be cool is to make it rainbow colors, you'd probably have to... Well, I was thinking make it change to a random color, but that probably wouldn't be like smooth transitions between colors. So I don't know how to do that. So this might be a one step at a time kind of thing. Either way, we've changed the color. So let's see. Change the material opacity. Okay, let's see. So we've got another discussion article here. I have an object set up in Unity, but the material has no opacity as a simple diffuse material. But at runtime, I do in fact want to change the opacity of the object. Do they have a standard script command that allows you to change the opacity at runtime, even if the material that is attached to your object does not have an opacity input? Opacity doesn't work with the default diffuse material. You need to set the material to use transparent or diffuse shader in order for opacity to work. Alpha start. Lerp. I believe you are looking for the color alpha. Renderer.material.color.a equals time.time dash math f.floor time.time. So I kind of understand this part, but that's fuzzy. So well, then let's just try this. Material.color.alpha. Okay. Unity. Unity. Scripting material.color. No, this is what I was just on. Well, then in this case, let's look through here. Render dot material dot color dot a. I see A. Alpha component of the color. 0 is transparent, 1 is opaque. Oh, opaque. Interesting. So what are these? Blue component of the color. G. Green component of the color. Ah, I understand. Red. RGB. Okay, it does colors through RGB, but the alpha. Ahaha. Okay. Equals 1.0 F. I messed it up. 1.0 F. Colon, but it doesn't like this. Cannot modify the return value of material.color because it's not a variable. Okay, I understand. But see, and then this color.lerp. What is lerp? Linear interpolation, maybe? Between colors A and B by T. Oh. I see. Sounds useful. Oh, material.color is the same as calling getColor or setColor with the property name of the main color as a parameter. And at this point, the word color just looks completely stupid. Hmm. But I think this is a good place to call it for the day. I got most of these done. I'm halfway there on these. If you're feeling confident, you can attempt the following as well. Modify any of the above changes so they change randomly each time the scene is played. Aiming for that, except I'm trying to make it change randomly while the scene's playing. And add extra functionality to the cube. For example, how might you change the color of the cube over time? And that is something that is kind of what I'm talking about with this. So implement your plane changes in the code, test the scene regularly, and let's see. Yeah, and then this just wants you to publish it all. So we'll get back to this. But 3 hours is a good first stream. Nothing crazy is happening, so we will get back to this. I'm probably gonna leave these materials right here, just so that I don't lose my place. But let's go ahead and do this. Let's try to do a little bit of a write-up before we go. So, today, we worked on the mod the cube, I guess, assignment. In Unity's learning pathways. So far, what we have accomplished is these. Is to change the cube's location. Change the cube's scale. Change the angle at which the cube rotates. And to change the cube's rotation speed. Of the remaining items, we have to change the color. We have to change the cube's material color and change the cube's material opacity or opacity. Although we made some progress on this. There is more to implement to display some level of mastery. Get on that next line. So let's see. We'll section these out. In addition, the advanced options are to modify these changes randomly and add functionality such as changing color over time. I intend to do this by making the cube move around the screen constantly while performing these changes. With the end goal making it look like a screensaver. Currently, I need to allow the movement to move in more than just a diagonal line. Diagonala. And to have the color change multiple times. As well as opacity and transition between colors. I will also need it to do these, no, to pick these colors randomly. Okay, that's our write-up for the day. I'll say we got about maybe halfway through this little project here. We accomplished a lot of the goals, but just to show mastery over this, we want to accomplish some things that are a little bit more in depth here. So I'll save this write-up as a guide for the next time I stream, which will probably be tomorrow. But other than that, that will probably do it for the day.